Okay, we're in section 2.5 and we're talking about the basic idea of continuity. And continuity in its most basic form simply means that if you are using your pencil to trace this, you don't have to pick it up and skip something. So like looking at this, we start here and we have to pick up our pencil here because there's a hole. That means that's a discontinuity. Going up here again, pick it up here, it's a discontinuity. All this is continuous, continuous, continuous. Discontinuity, because we have to jump down here. So these are the things that you need to understand about the basic idea of continuity. So now let's look at this. Does f of negative 5 exist? So negative 5 is here, we go up here. Does that exist? Yes, it exists. So check. Yep. Okay, does the limit of negative 5 exist? Is it the same coming in this way? No, of the 5 from the plus side. So coming in this way, yes, that's coming in. You can see it's coming in there. We have a limit. Okay, now does the limit of f of x equal what f of x at negative 5 equals? Yes, because it's there. Okay, if there had been a discontinuity there, it would be no. Is the function continuous at x equals negative 5? Yes, because we don't have to pick up our pencil there. Now I want to do similar, I want to do this again, see if it'll give me a better one. Okay, negative 2 here. So let's look at negative 2. Yes, this is what I wanted to do. Okay, you can see here, we're going to do both sides here. You can see here, does this exist? No, we have a hole here. This does not exist. So now, does the limit of negative 2 exist? Well, let's look at negative 2. Coming in this way, we can see that we would be getting here to 3. That exists. Coming in this way, we're also getting here to 3. So the limit here actually exists. Remember, we never have to actually get there. Does the limit of f of x at negative 2 equal f of negative 2? Well, no, because remember, this isn't here. There's nothing here. This doesn't exist. So they do not equal the same thing. Is the function continuous at x equals negative 2? No, because we have to pick up our pencil. So you can see here we did these two examples, the idea being here with the dot that is filled in and the dot that isn't. Well, we have limits. We don't necessarily have continuity. We don't necessarily have an actual existing answer to an equation, but we have a limit. So this really is an idea of that limit, that yes, it's approaching it. It never gets there, and so it doesn't really matter if we have these little breaks. But these are important concepts to understand as we go forward.